Hi, I'm back again, and this is our worksheet that we're doing on Monday, October 14th. And for those people that aren't here today, or if you just want a refresher on it, I want to talk about how to solve these problems. And I'm doing this in class, so this might be redundant, so this might be a useless video for you. But if you're not here, or if you just want to see it again, there's actually two different ways that we're going to look at solving problems today. One way is the straight guess method, and I'm going to do that first on this first problem. And I'm only going to solve the first problem, maybe the second problem on this. The rest you'll get some practice in class on. But this first problem, it's a speed and an acceleration problem. And it says a rocket travels upward from rest with a uniform acceleration of 4 meters per second squared. How far will the rocket have traveled in 8 seconds? Well, if I'm using the guess method, I'm going to open this up, and we start with, press the wrong one. We start with the idea that we write down our givens. And our given is 4 meters per second squared is our acceleration. And our time is 8 meters per second. Or, excuse me, our time is 8 seconds. Our unknown is the distance, how far. And apparently that's all we have. But remember, if you take a look at this, it accelerates upward from rest. So our initial velocity, 0. Now the guess method says, now let's find our one equation to solve a problem. And this is a great method if there is one equation to solve the problem. Where we'll find this equation is right here. It's on our reference sheet. And if you take a look, we are given initial velocity, acceleration, time. They want final velocity. Well, this doesn't have final velocity or acceleration. This has acceleration, and it has final velocity and acceleration, and initial velocity, and change in time. Oh, wait, they already give us the acceleration, so, well, they don't give us the final velocity. But still no distance. Here we've got distance, we don't have final velocity. And notice I'm looking at the formulas here, but if you read the words here, what we're doing is trying to match the words in the problem with the words here. This formula, though, says our distance, or our change in distance, is equal to the velocity times the change in time. Our initial velocity was 0. Our change in time was 8 seconds. And times 1/2 acceleration times our change in time squared. Oh, so there's our equation. And I'm just going to write it a little bit differently. Distance is going to equal initial velocity times t plus 1/2 at squared. We substitute. Distance equals 0 times 8 seconds plus 1/2 4 times 8 squared. And we solve. Distance equals, well, 0 times 8 is 0. 1/2 times 4 is 2. 8 squared is 64. So our distance equals 128 meters. And this is actually a pretty straightforward way of solving the problem. It works if the problem is a one-step problem. In a lot of our problems, they will be one step, but I've noticed a lot of people, even if they find the right equation, they forget that that's squared. And you'll actually see people come up with an answer of 16 on this. So, which is okay. I would give you partial credit on that. But the problem there is on a multiple choice test, you don't get partial credit. So let me clear this and show you another method that might not involve all that. And it's a shorter, it's simpler steps, but it is more forgiving. You don't have to worry about squaring things. So let's start with this again. A rocket accelerates from rest. I'll do this from rest. Our initial velocity equals 0. Our acceleration equals 4 meters per second per second. How far will the rocket have traveled in 8 seconds? Well, you know, our velocity equals our distance over time. This is our average velocity. Our average velocity is also v final plus v initial all over 2. So far this doesn't help because I don't have v final, but the key is the way I said our acceleration. I think I got the last problem wrong. I was saying our acceleration was 8, wasn't I? And it's 4. Okay, just so that we have something to compare, I'm going to change this to 8. It's not in the problem. So, how far, what's going on in 8? No, it is 4. I'm sorry. Boy, I really messed that up. Our acceleration is 4. So here's how we do this. We need to find v final. This is similar to the guess method, but it's more than one step. We need to find v final. So if we start with an acceleration of 4 meters per second every second, and it says 8 seconds. Well, that's 4 meters per second after 1 second. 2 seconds, it's 8 meters per second. 12 meters per second. 16, 20, 24, 28, 32. Our v final equals 32 meters per second. Now let's just average these. Our initial velocity is 0. Our final is 32. Divide that by 2. The average equals 16 meters per second. 16 meters per second time, now our distance equals velocity times time. I just rearranged this equation. And this gives me our distance is going to equal 16 times 8. If you do the math on that, it's 128 meters. So it's working out the same way for both of these things. So I hope this helps, and your job is to try and finish all the rest of these on this sheet. I really want you to think about this method of solving the problem, because this is something that we can keep track of in our heads and actually do problems. Sure, more steps. We don't plug into one equation, but each step is actually fairly straightforward, and it's easy for almost everyone to do. So I hope this helps, and may all your problems have solutions.